Yan. I think this session is now being recorded. Okay? Nag-alert pa sa inyo?
Yes po.
Okay. So, ang integral domains ay type lang ulit ng mga rings. Na in particular, ang integral domains ay commutative rings with unity na may isang particular na property. Ano yung property na ito? Let's see. To understand integral domains, let's start with a problem from algebra. Let's say this is a high school algebra problem, right? You're solving a quadratic equation. Now, the most efficient way to solve this is to first try to factor the quadratic polynomial whenever possible, no? Magta-try ka ng factoring. So, can you give me mafa-factor ba ito into binomials?
Yes, sir.
Yes po.
Anybody, what are the factors?
4
X
and
minus
3.
3, X minus 4.
X minus...
X minus 4, X minus 3.
X minus 3.
Yes. So, the factors are X minus 3 and X minus 4. Like so. No? And then, meron tayong isang particular property that we are using to proceed. What's next? Anong gagawin natin dito susunod? Or what are we teaching our students?
Equate po into 0.
Equate to 0.
Alin ang i-equate to 0?
Each factor po.
Each factor, no? Each factor will be equated to 0. So, pag in-equate natin yun sa 0, in other words, logically, what we're trying to imply is that whenever this product is equal to 0, it means to say that one of these factors must be 0. And therefore, either x minus 3 is 0 or x minus 4 equals 0. So, logically, this is the implication. It's actually a disjunction of two simple statements. Tama ba ako? Di ba ganyan yun? Kasi ang property na ginamit natin dito, ang key property na ginamit natin dito is the fact that whenever you have a product A times B and the product equals 0, you can always say that either A is 0 or B is 0. Hindi pa pwedeng none of A and B are 0 pero pero yung product naging 0. Hindi mangyayari yun sa normal na number system, right? So, either x minus 3 is 0 or x minus 4 is 0. That's why we can conclude that either x is 3 or 4. And therefore, we have two solutions for this given equation. Can you tell me kung anong tawag nyo sa property na yon na sinulat ko on the board? Meron ba kayong pangalan? May pangalan ba kayo doon sa ano na yun?
Zero product property, sir.
Zero product property. Yeah. In fact, that's also what I wanted to call that property. Now, the zero product property in the real number system states that if u and v are real numbers, so that their product is 0, either one of these factors is equal to 0. More generally, ito yung mas general. Kapag meron kang maraming real numbers, tapos ang product ay 0, it follows that one of the factors must be 0. Yan. Yan yung mas general na form ng zero product property. Okay? If you take the contrapositive of this statement, what is the contrapositive of this statement? Kasi ang contrapositive ay equivalent lang dun sa given na statement, right? So, what's the contrapositive of this statement? Anybody? Anong sabihin ng contrapositive? Ang statement kasi natin is of the form P, then Q. If P, then Q. Ito yung P. Ito yung Q. Ang contrapositive is the statement not Q, then not P. alam natin logically that these two statements are equivalent. So in other words, pag kinuha mo yung contrapositive, that is just an equivalent restatement of the given theorem. So can you tell me the contrapositive of this? Anybody? Raise your hand if you want to answer. Halimbawa, ang statement, for example, if it rains, then ano ba magandang consequence? Halimbawa, if it rains, then I will wash my car. For example. Ang contrapositive nun, i-negate mo yung conclusion and then i-imply mo yung negation ng premise. So, for example, if it rains, then I will wash my car. So, ang contrapositive niya, if I won't wash my car, then it will not rain. Parang ganon. So, in this example, can you tell me the contrapositive? Angelo. Yun si Angelo muna. Angelo Santos.
Medyo nalimutan ko na kasi sir. Ano lang, trigram po.
Okay, no problem.
If u is not equal to 0, then u is not equal to 0 or v is not equal to 0.
If u is not equal to 0,
then u is not equal to 0 or v is not equal to 0.
Ganito. Siguro, let's make the statement clear. Ang sabi ng statement, kapag ang product ng u and v ay 0, then isa sa u or sa v ang 0. So, kapag contrapositive mo yon, paano mo i-negate yung q? How will you negate this statement? Anong kabaligtaran ng isa sa u or sa v ay 0?
If none
None of them is 0.
equal 0, then uv is not equal to 0.
Very good. Who is that? Syra. Syra,
Yes.
is that you? Okay. So, kapag si u or v, kapag si u ay hindi 0 and si v ay hindi 0, then the product uv is not 0. In fact, that's the contrapositive. That's why, equivalently, we can say that the zero product property is also the following. Kapag hindi 0 yung u at saka yung v, end, no? Yung end. Yung or magiging end kapag ninenegate kasi. Diba? De Morgan's law. Yung product ay hindi 0. And Camille, are you saying something? Do you want to say something? Or you wanted to answer?
Sir, okay na po. Nasa ganun.
Okay, thank you. So, alin man dito sa dalawa ay pwede nating tawaging zero product property in R. Okay? But, in general, in rings, the zero product property is does not hold in general. For example, when you look at the integers modulo 12, now in the integers modulo 12, we're doing addition and multiplication modulo 12. When you say modulo 12, we add and multiply as usual, but to get the answer, yung usual product and sum, kinukuha natin yung remainder when you divide by 12. For example, 3 times 4 in the normal number system is 12, but then we're doing it modulo 12, and since 12 is divisible by 12, the remainder is 0. That's why 3 times 4 is 0. So in other words, in the ring z sub 12, and 3 times 4 is 0, but as you can see, neither 3 nor 4 is 0. So this poses some kind of a problem, no? Kumbaga, sa real number system, the zero product property holds. Ginagamit natin itong zero product property sa pagsosolve ng quadratic equations and polynomial equations, di ba? So, ibig sabihin pala kapag ang polynomial ko ay over z sub 12, when I say that, sabihin yung coefficients mo nasa z sub 12, hindi mo pwedeng gamitin yung technique na ginagamit natin doon sa algebra problem na yon. Naintindihan nyo? So, z sub 12 does not admit the zero product property. Also, in the ring of 2 by 2, 2 by 2 real matrices, ang laman nito mga matrices na 2 by 2. Ganyan ang elements niya, no? Ang addition nito ay entry-wise. Ang multiplication ay kakaiba, no? Paano nagmo-multiply ng dalawang matrix? Meron ako tinuro sa inyo last time. Ito yung matrix A, ito yung matrix B. The product will be placed here, di ba? So, paano kinukuha yung product? You take rows by columns. Take the dot product. Ganon, di ba? Bawa, dito, 1 times 1 plus 1 times negative 1 is 0. Okay? And then, ay, mali yata ako. Negative 1 to. Yeah. And then, 1 times 1 plus 1 times negative 1, 0 ulit. Tapos ito, huwag na tayo maglokohan. Lahat yan 0. Ito naman, manggagaling ito from here at ito, no? Ito naman, manggagaling to from here, tsaka ito. So, the product really is the 0 matrix. So, as you can see, these two matrices are non-zero, but then their product is 0. And that violates the zero product property. Meaning to say, even in the ring M2R, the zero product property cannot be assumed. Okay? So, ito yung property ng R lang. Hindi natin sinasabing R lang pala. Property ito ng R, but we cannot say that it's a property of every kind of ring. Okay? Right. Let's have the following definition. Because of these problems, nagkaroon tayo ng mga definitions na ito. So, let's say R is a ring. Okay? A non-zero element, little r, is called a zero divisor of the ring. Yun ang terminology. If you can find a partner, a non-zero partner for R, so that either the product RS or the product SR is 0. Kung halimbawa, look at the previous example. Halimbawa, itong 3, zero divisor yan ng Z sub 12. Why? Kasi I can find a partner for 3 which is also not 0, yet their product is 0. So, si 3 ay zero divisor. In fact, si 4 also is a zero divisor because ang pwede may partner sa kanya si 3. Di ba? Itong matrix na ito, itong matrices na ito, are zero divisors. They are partners of one another. Do you understand? Do you understand me? Ang tawag natin sa mga elements na hindi naman zero, pero kapag nag-multiply ka, nagiging zero. Ang tawag natin din mga zero divisors. Do you understand me so far? Oy, reactions. Thumbs down kung di nyo na nagigets, ha? So, zero divisor, ang tawag dun sa mga elements na hindi naman zero, yet makakahanap ka ng non-zero partner so that the product is 0. Did you understand? And sila yung mga dahilan bakit hindi nag-hold yung zero product property. Now, what we wanted today is we wanted to have a ring that admits the zero product property. Mangyayari lamang yun kung ang ring mo ay walang zero divisor. Alright? So, this is now the definition. A commutative ring with unity. So, requirement, commutative ring with unity, with 1, yung ring mo, that has no zero divisors is called an integral domain. So, simply saying, kapag sinabi nating integral domain, this is a place where we can assume the zero product property. Ito yung mga rings na may zero product property. O yung mga commutative ring with unity na may zero product property. Do you understand? Patatandaan niyo, ang integral domain, ang keyword, zero product property. So, a commutative ring with unity is an integral domain if and only if the zero product property holds. No? Yan. Tawag natin yung zero product property. Ulit, ano sabihin ng zero product property? Kapag ang product ng UV is 0, either U is 0 or V is 0. Examples of integral domains are the following. You know the ring 2Z. Pag sinabing ring 2Z, ito yung mga even integers. Okay, and definition ng 2Z. Ring ito eh. Tapos, commutative ring with mali. May mali pala dito. I'm sorry. Lumang slide ito eh. Ganito. I will tell you what's the problem with this example. Kaya ako sinulat yung 2Z. Kasi, sa ibang libro, tingnan yung definition natin ng integral domain. Ang integral domain is a commutative ring with unity by default. Okay? Sa ating definition. But some books, there are also some books where hindi nire-require na commutative yung ring at hindi rin nire-require na may unity. Kapag hindi mo na-require yung 2Z, magiging example ng integral domains. Kaya, based on our definition, dapat yung 2Z, hindi siya example ng integral domain. Kaya lang, siguro ito nung ginagawa ko, I was not mindful, na tinatype ko yung slide na to, I was not mindful na nire-require nga pala natin na commutative ring with unity. So, based on our definition, kasi the definition sometimes change from one author to another based on the need or on the purpose. Naintindihan nyo? But basically, ang main ingredient ng integral domain ay yung zero product property. Kung may unity man or wala, kung may, what do you call this? Kung commutative man or hindi, it depends from one book to another. Babasahin nyo palagi yung definition. Okay? But for our purpose, i-require ko na commutative ring with unity lahat ng integral domains. Bakit walang unity yung 2Z? Wala siyang 1. No? Yung 1 is not even. Although may zero product property dyan, pero hindi siya integral domain based on our definition kasi nga wala siyang unity or 1 is not an element. Now, all of these guys, yung mga number systems natin, yung mga integers, yung mga rational numbers, real numbers, set of complex numbers, they are all integral domains because they all admit the zero product property. But as we have seen, yung ring of matrices natin is not an integral domain because you can find non-zero matrices which multiplies to 0. Also, as per our example, z sub 12 is not an integral domain because you can find non-zero elements whose product is 0. But now, look at the multiplication table of z sub 5. Hindi ko na sinama yung 0 kasi kahit sino namang i-multiply mo sa 0, 0 rin, no? Ano ang ibig sabihin ng multiplication sa z sub 5 ulit? Halimbawa, bakit ang 3 times 4 ay naging 2? Can somebody explain?
2 po ang naging remainder niya, sir.
Kapag
3 times, 3 times 4 po ay 12.
yes, tapos pag
Opo,
divide sa
tapos
5,
may remainder po na 2.
yes, kaya ang product ay 2. Ang z sub 5 kasi, for those who have just now come, 5 lang ang elements, no? 0, 1, 2, 3, 4. Kaya kapag lumalagpas ka sa 4, kinukuha mo yung remainder when you divide by 5. Okay? Kaya ang 3 times 4 ay 2. Parang clock arithmetic ito. Okay? Now, do you think z sub 5 is an integral domain? Look at this non-zero elements. Hindi ko na sinama yung 0 kasi pag integral domain, interesado lang tayo sa mga non-zero. Kailangan ng product nila non-zero. Yung mga products ba ng mga non-zero elements na to, non-zero rin? Meron ba lumabas na 0 dyan?
Wala po.
Wala, di ba? So, what does that mean? Commutative ring with unity to, tapos walang zero divisors. Ano tawag natin sa z sub 5?
Integral domain.
Yes.
Integral domain.
Integral.
Z sub 5 is an integral domain. No? Pero yung z sub 12, hindi. Okay? Okay. So, may tanong na naman tayo sa isip. Kailan kaya nagiging integral domain yung z sub n? Ano kaya ang values ng n? Yung z sub 12, hindi. Kasi may 3 times 4 dun. Pero yung z sub 5, integral domain, no?
Kapag ang n po ay prime number po.
Kapag yung n ay prime. But that's the answer. But how do we justify that? We will see. First of all, we prove the following theorem. Basta ang ring ay isang field, ano yung sabihin ng field? Commutative ring with unity kung saan lahat ng non-zero elements ay may multiplicative inverses. Halimbawa, the set of real numbers. Lahat ng non-zero elements nun may multiplicative inverse, diba? Pa set of rational numbers. Ang non-zero na rational, may reciprocal na rational number din. Pero, yung ring of integers is not an integral domain, is not a field kasi, for example, yung 2, ang multiplicative inverse niya ay 1/2, pero yung 1/2 ay hindi naman integer.
Not element.
Yes. That's the reason why the field, the ring Z is not a field. It's only, well, a commutative ring with unity. Basta daw ang ring ay maging field, automatic siya ay integral domain. Let's see why. So let's say F is a field. Kuha tayo ng dalawang elements ng F whose product is not zero. What I wanted to prove here is that F is an integral domain, therefore I wanted to prove that F has the what they call this? Zero product property. So ang gagawin natin, ang zero product property states that whenever the product of two elements is zero, then one of these is zero. So parang ganito. Kukuha ko ng arbitrary elements ng F, i-multiply ko, and I suppose that the product is zero. Kailangan ko mapatunayan na isa sa U or sa V ay zero. First of all, kung si U, mamaya na yan. Kung si U ay 0, tapos na. Diba? Kapag si U ay 0, tapos na tayo. Isa ay, yung isa sa kanila ay 0. The proof is done. Paano kapag hindi 0 yung U? Ito yung gagawin natin. Pag hindi 0 yung U, si F kasi ay field. So, yung U na yan ay unit. Yun pala yung term natin. No? Naalala nyo? Pag sinabing unit, may multiplicative inverse siya. Okay? So, U inverse exists. Tignan nyo ngayon to. Gagamitin ko yung U inverse. I start with V. What can you say about V? V is 1 times V. 1 is the unity. Now, itong 1 na to is equal to U inverse times U times V. And then, I'm going to use associativity in the multiplication. But because UV by hypothesis is 0, I can replace this by 0. Anything in the ring when multiplied by 0 is 0. Ang naging conclusion is that kung si U ay hindi man 0, sino raw ang magiging 0? Si V. That's it.
V.
So parang ganito mangyari kasi ang totoo naman kapag meron kang U, either it is 0 or not. If it is 0, we're done. If it is not 0, sino raw ang 0? Si V. So, therefore, logically, it says that either U or V is 0. Therefore, F is an integral domain. So, tandaan nyo ha, lahat ng field ay integral domain. Ang tanong ngayon, lahat ba ng integral domain ay field? Kasi, parang no? What do you call this? Lahat ng field, parang lahat ng babae ay tao. Ang tao ba dapat babae? Parang ganun yung logic niyan, di ba? Meron ba tayong counter example dito? Siyempre yung sa babae at saka sa tao, may counter example tayo yung mga lalaki. Hindi ba? Pero dito, tingnan nyo, lahat ng field ay integral domain. Lahat ba ng integral domain ay field? Of course, ang sagot dito, ine-expect natin to be no. Kasi, kung ang integral domain din ay field din pala, so wala pala pinagkaiba ang fields at integral domain. There's no need for a new definition. Naintindihan nyo? So, ang ating Venn diagram, ito yung mga integral domains. Tapos, ayan yung mga fields. Yung mga fields parang maliit na portion lang yan ng mga integral domains. No? Right? By the way, dagdagan natin yung Venn diagram. Meron pang isang malaki dito. Nandito yung mga commutative ring with unity. Okay? Ito yung mga commutative ring with unity. Ganyan ang ating diagram. Ang Venn diagram. Ang tanong ko dito, meron bang rings na integral domain pero hindi field? Anybody? Talaga bang mas maliit yung set of all fields? Can you find a good counterexample? Integral domain siya, may zero product property, pero hindi siya field. Nabanggit ko na kanina yun. Ano kaya ang example? Anybody? Naku, mauubos ang oras natin. Nabanggit ko na kanina. Yung ring of integers. Yung ring of integers hindi siya field. Yet, it is an integral domain. Hindi ba kapag meron kang dalawang integers, isipin mo may dalawa kang integers, minultiply ko, sabi ko, ang product ng dalawang integers na to ay 0. Anong mako-conclude nyo? What can you draw from that statement? Di ba, you can already deduce that one of them must be 0. Tama ba ako? Am I right? Okay. So, see, set of integers, ring of integers ay integral domain, but it's not a field kasi hindi lahat ng non-zero element ay may multiplicative inverse na integer din. Pag sinasabi kong may multiplicative inverse, I mean to say, kasi yan ba yung 2? Meron naman siyang multiplicative inverse, but not as an integer. Did you understand? Ang multiplicative inverse niya kasi ay 1/2. Now, syempre, in-expect natin, hiniwalay natin yung mga integral domains from the field. So, merong something sa mga integral domains. I mean, may advantage kapag ikaw ay integral domain. Ang isa sa mga advantage ay ang sumusunod, yung tinatawag natin cancellation laws. No? Ito yung tinatawag natin cancellation laws for integral domains. Lahat daw ng integral domains may property na ito. Ano yung cancellation laws na ito? Ito yung ginagawa nyo sa algebra dati. Diba sa algebra, pag meron kang 2x equals sa 4, no? Kunwari ganyan. Eh diba ang 4 ano lang? 2 times 2. Diba? Because 2 is not 0, you can cancel. And conclude that x is 2. Ang tawag natin dito ay cancellation laws. It turned out that the cancellation law holds for every integral domain. In fact, tingnan nyo ha, the following are equivalent statements. Ang ibig sabihin nun, hindi ko sinasabing true ito or true ito. Ang sinasabi ko, pag isa dito sa 1 or sa 2 ang true, yung isa rin ay true. Yan ang sabihin na equivalent. Pag isa dyan ay false, yung isa rin ay false. So let me erase this. Ano statement number 1? This is an integral domain. Number 2, cancellation property. Ano yung cancellation property? If you have 3 elements A, B, and C from D, where A is not 0 and AB equals AC, ang conclusion is that B is equal to C. So do you understand the cancellation law? This is somewhat familiar, right? This is something that you are using in almost every day in your algebra life, di ba? So, kapag daw may ganitong property, pag daw integral domain, may ganitong property. Kapag daw yung commutative ring with unity mo may ganitong property, integral domain siya. Vice versa. Again, when we say integral domain, it simply meant to say that it admits the zero product property. Lagyan nyo pa ulit-ulitin yun para maalala nyo. So for the proof, we will first prove that statement 1 implies statement 2. So pag ganyan, we will assume statement number 1. So let D be an integral domain. We will pick 3 elements A, B, C from D, and we will assume that A is not 0, yet AB is equal to AC. So we need to prove that B is equal to C. Paano mag-equal yung B sa C? Ganito. Pansinin nyo lang na ang A times the parenthesis B minus C by distributive property is AB minus AC. But by hypothesis, AB is equal to AC. So what's AB minus AC? That's 0. Therefore, the product A times B minus C is 0. Because we are working in an integral domain, the zero product property can be used to conclude that either A is 0 or B minus C is 0. But by assumption, A is not 0. So what will happen now? Halimbawa, either you are maganda or mayaman, pero hindi ka naman maganda. Anong conclusion? Mayaman ka. Nakuha niyo yung logic. Wala akong sinasabing true yung ano na yun, ha. I mean yung antag na to, logical implications lang ang pinag-uusapan natin. So either A is 0 or B minus C is 0, but A is not 0. Therefore, B minus C must then be equal to 0, implying that B is equal to C as required. Nakuha nyo? This is the proof of statement 1 implying statement 2. Of course, because we're proving equivalence, we have to do the opposite direction. So we're now assuming statement number 2. Kunwari nag-hold ito, yung cancellation property. Na kunwari nag-hold siya. Bakit si D ay integral domain? Bakit nag-work yung zero product property? So this is what we're going to do. So assume statement 2 holds. And then, let's pick 2 elements U and V so that their product is 0. Okay? Pumili raw tayo ng dalawang, what do you call this? Yeah. Pumili tayo ng dalawang elements na ang product ay 0. So, to prove that this is an integral domain, what do we want to say in the end? We wanted to prove that either U or V is what? 0. Paano mangyayari? Yan. Ganito. So, suppose ko hindi 0 yung U. Sabihin na lang natin. Okay, ganito. Then, ang U times V ay 0 by assumption. At the same time, that equals U times 0. Because in any ring, any element multiplied to 0 is 0. Correct? As you can see, equal yung U times V sa U times 0. There's a common factor U, and that common factor is not 0. Because we're assuming cancellation property, we can cancel U and conclude that V is 0. Therefore, kung hindi raw 0 si U, si V ang 0. Dalawa lang naman pwedeng mangyari, either 0 si U or hindi. Kung 0 siya, tapos na. Kung hindi siya 0, sino raw ang 0? Si V. Therefore, either U is 0 or V is 0, proving that D has the zero product property and therefore it is an integral domain. Kakasunod pa ba? Do you still follow? Okay. So sabi natin, ano sabi natin ba? Lahat ng field ay integral domain, pero may mga integral domain na hindi field, kagaya ni Z. Okay? Kagaya ng mga integers. It turned out na ang pagiging field at pagiging integral domain ay nagkakaiba lamang kapag infinite yung ring. When you say pag infinite yung ring, kapag yung ring ay may maraming elements na hindi finite. Okay? Kasi alam nyo, according to the next theorem, kanina, ang mga integral domains hindi kailangang field. Okay? Pero kung finitely many elements lang meron yung integral domain na yun, halimbawa yung z sub 5. Yung z sub 5 kanina, integral domain siya, di ba? Tapos finite siya. Ano yung pwede natin conclude? Field siya. So sa madaling salita, wala palang pinagkaiba ang field at mga integral domains kung finitely many elements lang ang meron tayo. Did you understand me? In general, an integral domain need not be a field, especially when these things are infinite or when these sets are infinite. Pero for finite case, lahat ang integral domain basta finite, automatic siya ay field. Bakit? Ano nagagawa ng finiteness na yon? We will see. We will see. So halimbawa, kunwari si D ay finite na integral domain. Okay? Integral domain, may zero product property, tas finite lang. Kunwari may n elements. Hindi natin alam kung ilan, basta finite. To prove that it is a field, what we ought to show, or what we need to show, is that every non-zero element of D must be a unit, or must have multiplicative inverse. That's what we wanted to do really. Okay? So, ganito. We will pick an arbitrary non-zero element of D. Let's say, U. Pumili ka lang na isa. And then, we're going to show that U has a multiplicative inverse. Ang tanong, saan kamay ng Diyos natin kukunin yung multiplicative inverse na yan, no? Saan mo kukunin, or how will you show that that exists? Now, this is not easy. In fact, this proof is really elegant. Sa math, may mga ganitong klaseng proof. Sa totoo lang, minsan kapag ikaw ang mag-iisip, paano kaya naisip yun? Ang may isip mo, paano kaya naisip yun? Ang galing naman. Masusundan mo yung proof, pero kung paano siya inisip, kung paano siya gagawin, minsan it will take time and experience to actually understand. No? So, this is the trick. This is one of the proofs that I know. Maraming iba't ibang proofs, no? Ang gagawin natin, magko-construct ako ng function out of the element U, gamit yung element na U. Magko-construct ako ng function from D to D. Ang function na lambda U, tatawagin ko lambda U. Tunog coronavirus, no? Lambda U. Diyos ko, mauubos ang Greek alphabet natin, di ba? Tapos tong pandemic na to, visit. So, ang pangalan ng function ko ay lambda U. It takes elements of D to elements of D. Pag may element ka ng D, ipaprocess siya ng lambda U to some other element of D. Yan ang ibig sabihin nito. Ano yung rule? Or ano yung formula? Ang formula ganito, pag nag-input ka ng X, ang gagawin ng lambda U sa X, imumultiply niya lang sa kaliwa by U. Kaya nga may parenthesis dito. Lambda U is just left multiplication by U. Alam niyo na ba't lambda ginamit ko? Kasi lambda U is just left multiplication. Anong ginagawa ng lambda U? Nagmumultiply lang by U sa kaliwa.
Left.
Halimbawa, magbigay ako ng example, ha? Ano ba yung Z sub 5? Yung paborito nating Z sub 5. 0, 1, 2, 3, 4. Yan. Ang U, kunwari na kinuha ko, anong gusto nyong U? Kunwari 2. How do I show that 2 has a multiplicative inverse? I-construct mo yung lambda U. No? Paano ginagawa yung lambda U? Ganito. 0, 1, 2, 3, 4. Ang gagawin mo, multiply mo lahat sa kaliwa by 2. 0 times 2, 0. 1 times 2, 2. 2 times 2, what? 2 times 2, 4.
4.
3 times 2,
1.
1. 4 times 2,
3.
3. Nakuha nyo ba? Ito. Ganito yung mangyayari sa proof. Nakita nyo dito sa mga product, may lumabas na 1. Tignan mo to. Ang sinasabi niyan, lambda 2 of 3 is equal to 1. So that means to say that 2 times 3 is equal to 1. So therefore, 2 inverse is actually 3. Kasi ang product nila ay 1. Naintindihan niya? Yun yung technique. At this is one way to determine kung ano yung multiplicative inverse ng u, ng 2. Alam mo, magpalit ka ng u. Let's say, this time ang u na kukunin ko 4. Sino kaya ang multiplicative inverse ng 4? Ang gawin mo, buuin mo yung lambda 4. Ang lambda 4, ang ginagawa na ito, mumultiply mo lahat sa 4. Multiply mo lahat sa 4. 0 times 4, 0. 1 times 4, 4. 2 times 4, 3. 3 times 4, 2. And 4 times 4, 1. Oh, lumabas na naman si Van, no? So, titignan mo to. So, that meant to say lambda 4 of 4 is 1. Or 4 times 4 is equal to 1. Therefore, 4 inverse is itself. Nakuha niya? So, ang tanong na lang natin dito, ba't gumagana yung lambda u? Bakit, ang ano dito, ba't sure kayo na laging lalabas yung 1, no? Ba't sure tayo na laging lalabas yung 1? So, that's the question. Kasi kapag lumabas na itong 1, finish na. May multiplicative inverse na. 'Di ba? Definitely hindi yan lalabas dito sa 0 kasi 0 yun eh. 0 times anything is 0 eh. Ang reason is the fact that this function is actually 1 to 1. Ano ibig sabihin natin ng 1 to 1? Ang ibig sabihin ng 1 to 1 siya, kapag lambda u of x1 ay nag-equal sa lambda u of x2, magka-follow na ang x1 ay equal sa x2. Yun ang sabihin ng 1 to 1. Equivalently, kapag ginawa yung contrapositive, pag hindi parehas yung x1 at x2, yung mga lambdas nila ay hindi rin parehas. Do you understand? Pag function kasi, pag sinabi mo 1 to 1, dalawang magkaibang bagay pupunta sa dalawang magkaibang bagay. Paano pa yung direction? Dalawang magkaibang bagay, dapat ang images nila magkaiba rin. Hindi pwedeng magpunta yung dalawang magkaiba sa iisa lang. Hindi yun 1 to 1, many to 1 na yun, di ba? Pag 1 to 1, pag magkaiba yung dalawang bagay, yung mga images nila dapat magkaiba. Pero bakit nga ba 1 to 1 yung lambda u? Bakit 1 to 1? Kasi, kung dito ka mag-start, ang implication niyan, ux1 is equal to ux2. Diba? Eh si u hindi 0. Tapos common siya on the left. Aha! We are in an integral domain, therefore we can cancel and conclude really that x1 is equal to x2. This is why lambda u should be 1 to 1. Naintindihan nyo? Eh ngayon, kung 1 to 1 to, walang nauulit sa mga images. No? Magka-follow ngayon na si lambda u ay bijective na. Pag sinabing bijective, parang yung yung limang daliri mo sa kaliwa, limang daliri mo sa kanan, magmamatch sila in some way. Walang may iwanang walang kapartner. Yun yung isabihin ng bijective, no? Parang permutation siya ng limang daliri mo matching your other 5 fingers, no? Parang matching siya ng 5, ano ba? Pag ganyan. That's a bijection. Ayan, this is a bijection. Naintindihan nyo? In some fashion. Parang yung listahan ko kanina, di ba? Yung lambda, di ba? Lambda 2. So, C sub 5 tayo. 1 times 2, 2 times 2, 4, 3 times 2, 2 times 3 is 1, 2 times 4 is 3. Nakita nyo, no? May umulit ba sa images? Wala. So, kung walang uulit, finite yan, ito yung magagawa ng finiteness. Kung finite lang yan, ibig sabihin, ang ibig sabihin ng onto, ulit, yung 1 to 5, mag-a-appear lang ulit siya, 0 to 4, mag-a-appear lang siya at least once dun sa mga images. In particular, si 1 ay mababanggit. Ibig sabihin, there will exist some v in D where lambda u of v is exactly 1. Ibig sabihin sa kanan, mag-a-appear si 1. And with this definition, uv is equal to 1. That proves that u is a unit and its inverse is v. Intindihan nyo? Did you get the proof? Hindi lahat ng details ng proof ay nasa slide because I cannot put them all in one page, no? Of course. Did you get the proof? The proof is so nice, no? Yung nakaisip nito must be genius kasi hindi mo naman talaga pinakita kung sino yung inverse, na? Na-prove mo lang na the inverse will exist somehow using these mathematical properties, no? That's the beauty of this theorem. Okay? So meron tayong isang aspect ng ring na pag-aaralan or mababanggit palagi. Yung tinatawag nating characteristic of a ring. Ano yung characteristic of a ring? Now, in some rings, halimbawa, sa Z sub 5, burito natin to, no? Tignan nyo. Lahat ng element dito, pag inad ko sa sarili niya ng 5 beses, 0. Yan, no? Add mo sa yung mga elements yan ng 5 beses. Ano ba yung 2 plus 2 plus 2 plus 2 plus 2? 10 yan eh. Modulo 5, 0. 3 plus 3 plus 3 plus 15. 0. Diba? 4 plus 4, 20. 0. Na? And 5 is the smallest number na mangyayari ito. Ang tawag natin dun sa 5 na yon, you call that the characteristic of the ring. Anong definition natin ng characteristic of a ring? It is the smallest positive integer, n, so that NA is equal to 0 for all A in R. Ano yung sabihin natin ng NA? NA is shorthand for A plus blah 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 plus A, where you get the term, where you get n copies of A. Naintindihan nyo? Now, sometimes in a particular ring, this may not happen. Halimbawa, in the ring R of real numbers, ang 1 ba, pag inad ko ng inad sa sarili niya, eventually magiging 0 ba yan? Diba never? Kasi ang 1, 1 plus 1, 2, 1 plus 1 plus 1, 3, 1 plus 1 plus 1 plus 1, 4. Magiging 0 ba yan eventually? Never. If no such integer exists, we just define the characteristic to be 0. So pag sinabi natin the characteristic is 0, there's no way these elements could add up to become 0. Naintindihan nyo? Can I proceed? Lahat ba nasundan nyo? Okay? Nasundan ha? Sige. Alright. So, yun ang isipin natin ng characteristic. Halimbawa, ang Z sub 3. Ano kayang characteristic ng Z sub 3? What do you think? Modulo 3 tayo. Anong characteristic ng Z sub 3? So, ang characteristic ng Z sub 5, 5, no?
3 rin.
3 rin, no?
3 also.
Yes, yes. Kapag inad mo yung bawat isa sa sarili nila ng 3 times, nagiging ano, kasi nga modulo 3 tayo. Sa Z sub n, medyo madaling malaman yung characteristic, no? Pero halimbawa, yung characteristic ng integers, just look at the element 1. Yung integer ba na 1, pag inad ko sa sarili niya ng maraming beses, pagiging 0 ba yan eventually? Never, di ba? Kasi number pa rin naman yan eh. Kaya ang characteristic na ay 0.
0.
Okay. Nagets nyo, ha? O, sige. Now, in case that the ring has a unity, 1, and it has a positive characteristic, ibig sabihin hindi 0 ang characteristic, then the characteristic is the smallest positive integer n, so that n times 1 is 0. Ibig sabihin na ito, kapag may unity yung ring mo, ang kailangan mo lang tignan yung unity. Wag mo, kasi tingnan yung definition, for all A in R. Ibig sabihin, kailangan ko bang itest isa-isa lahat ng mga elements? If the ring has a unity, you only need to check the unity. Halimbawa sa Z sub 5, kalokohan pa lang i-check mo isa-isa. Yung 1 plus 1 plus 1, 2 plus 2 plus 2. Kalokohan yun, mauubos yung energy mo. Because in math, we always would like to minimize the energy used, di ba? So, you only have to look at the element 1. Tignan mo lang daw si 1. Mga ilang 1 ang kailangan ko para mag-0. Yun lang ang kailangan mong malaman para malaman mo yung characteristic. And the answer is 5. Pag nabilang mo siya sa 1, mangyayari siya sa iba. Bakit? Ang reason, tingnan nyo. Pag meron kasing arbitrary A sa ring, at si n ay positive integer, ang NA kasi ganito. Tapos ang bawat A, pwede mong isulat as A times 1. Right? And that's the same as A times 1 plus 1 plus 1 by distributive property. Kaya kapag 0 na ito, 0 na rin ito. So, to get the algebra behind that, kaya you only need to check yung 1. Kung meron mang 1 yung ring. Of course. Naintindihan nyo ba? Kasi may mga rings na walang 1 di ba? But in that case, kung meron mang 1, swerte ka, ang kailangan mo lang tignan yung 1. Okay? Kasi pag nag-0 na ito, 0 na rin ito for any A because of the distributive property. Ito na naman tayo. Well, lahat pala ito ay may characteristic na 0. Yung mga number rings, yung mga ring of numbers, all of them have characteristic 0 kasi yung mga elements nila, especially yung mga hindi 0, hindi pwedeng mag-add up to 0. Halimbawa, 2 plus 2 plus 2 plus 2 plus 2, never yan mag-0 in these rings. Right? Ang Z sub n, gaya nga ng sabi nyo kanina, ang characteristic niya ay n. Kasi yung 1 yan, you only need n ones to get 0. Oh my gosh, what is this? Okay, so this is an example from last meeting. If X is a non-empty set, the ring Z2X. Anong laman ng Z2X? Ito yung mga functions from X to Z sub 2. Ang laman ng rings natin, mga functions. Ang addition natin dito, function addition. Ang multiplication ay function multiplication. Yung pointwise addition tsaka pointwise multiplication. Lahat ito ay may characteristic na 2 dahil dun sa Z sub 2. Halimbawa, example lang. Magbigay tayo ng particular X. Kunwari ang X ay A, B. Naalala nyo last time yung Z2X may 4 na elements? Naalala nyo ba to? Hanapin ko nga yung last time para lang makita nyo. Wait lang ha. Let's switch slide. Ito yung last meeting na na lecture. Hanapin natin siya.
0001.
Ito yan.
Yung may zeta.
Very good. Ito yan. Ayan yun. Pansinin nyo, ang 0 dito yung zeta. Kasi, yan yung function na nagdadala sa 0. No? Pansin nyo ba yung diagonal ng addition table, puro zeta or puro 0? Ibig sabihin na ang diagonal ay puro 0. It meant to say na pag yung elements inad mo sa sarili niya, nagiging 0. So, any element when added to 0 is 0. So, ang characteristic ay 2. Kasi you only need 2 times, para maging 0 yung sum. Did you understand? Okay, so ito yung may characteristic na 2. Yan. For an integral domain, something is quite nice. Ano sabi nito? Sige nga. Ano sabi nito? Can you somebody explain? And what do you think will be the most important consequence? Why do we want this theorem to happen? Can somebody read this theorem, please? Internalize natin yung theorem, please. Somebody please read the theorem. Please raise your hand so I can call you. Uy. Angelo, thank you.
If D is an integral domain, then the
Characteristic of D. If D is an integral domain, then the characteristic of D is either 0 or prime. So, pwede bang pag integral domain yung ring ko, pwedeng ang characteristic ay 4? No. No, pwedeng 2. Pwedeng 3. Pwedeng what?
5.
5.
Yan.
Seven.
Ganyan. Pwedeng 0 rin, ha? Pwedeng 0. Either 0 or prime. So, what do you think is the most important consequence of this? Doon ako na-excite. Yung kayo makarealize, ano kayo naging consequence na ito? Hindi nyo naalala yung previous example ko. Yung, balikan nga natin. Ayan, nandyan, oh. Ito, specifically. Ang C sub n, ang characteristic ay n. Hindi naman pwede maging 0 yung n. So, kung gusto mo maging integral domain yung Z sub n, ano lang ang pwedeng n?
Prime.
Prime.
Very good. Kaya pala, since last meeting, no? Di ba tanong natin last meeting, kailan nagiging field si Z sub n? Meron tayong hula. Pag ang n ay prime. That's only our guess, but we did not prove that. But right now, we already know why that is the case. Kasi, pag ang C sub n ay, pag si n ay prime, pag ito ay integral domain, ibig sabihin yan si n ay prime. In fact, kapag si n ay prime, siya rin ay integral domain. Okay? Finite yan. Ang mga integral domains at fields ay iisa lang kapag finite yung ring. So, I think meron na tayong sagot doon. So, why is this the case? This is the proof. So, pag nagpo-prove kayo ng either 0 or dot, ang style ng proof ganito, ine-negate nyo yung isa. Kunwari hindi totoo yung isa. Kailangan nyo ma-prove na mag-hold yung isa. Ganon yung direct proof kapag or ang conclusion. Ine-negate mo yung isa, you have to show the other alternative will follow. So, for example, suppose that the characteristic of D is P and P is not 0. So, hindi raw ito. Kailangan nating i-prove na si P ay prime. Okay? May tanong ako. First of all, why can P be 1? Bakit hindi pa pwedeng 1 yung characteristic? Ano bang mangyayari kapag...
P is not a prime.
Hindi, yun yung gusto nating marating. I mean, yun yung dapat na conclusion. Alam ko ang 1 is not prime. Pero, why would it follow that P is prime? P must be prime. Ang tinatanong ko muna, bakit hindi pwedeng maging 1 yung characteristic? Ano bang ibig sabihin kapag 1 ang characteristic? Sabihin, anything multiplied by 1 will be 0. Diba? Anything multiplied by 1 will be 0. So, that means to say that every element of the ring will be 0. So, yung ring mo, magiging 0 lang ang laman. That can't be because D is an integral domain. It must have a 1. 1 is different from 0. So, the characteristic cannot be 1. Otherwise, magiging isa lang yung element ng ring mo. Magiging ganyan lang. Did you understand? To prove that P is prime, we're going to do an indirect proof. Okay? Suppose mapa-factor natin si P into factors R and S, where both R and S are greater than 1 but less than P. Di ba kasi kapag prime, greater than 1 yan, tapos ang tanging factors niya lang, itself and 1. Kunwari, mafa-factor mo siya in a non-trivial way. When I say non-trivial way, I can split into R times S, where R and S are something bigger than 1. Okay? And less than P. Ito yung mangyayari. When I look at R1 times S1, ang isipin ng R1, by the way, is just 1 repeated R times. When I say S1, it's 1 plus 1 plus 1 plus 1 repeated S times. Now, applying distributive property, ano mangyayari dyan? Kasi nga, let me give you an example para lang makita nyo. Actually, 2 times 1 times 3 times 1. Ang isabihin na ito, 1 plus 1 plus 1, 1 plus 1 times 1 plus 1 plus 1. Ang distributive property, yung parang mga drawing yung mga ganito-ganito, di ba? O, sige. O, di 1 times 1 plus 1 times 1, nakailang 1 na ako so far. 3 na. Ito pa. Sorry. Ito pa. 3 1 pa ulit. Ilang 1 yan? 6 to. Ito 2. Ito 3. In general, yung sagot, mga ilang 1 ang lalabas. Pag nag-a-apply ka kasi ng distributive property, you are pairing each term to every term. Diba? Ganun yun. Ilang terms ba meron dito? R. Ilang terms meron dito? S. If you're going to pair everyone from this expression to everyone in this expression, in
Product of RS.
yes. So there will be a lot of ones, but then there are how many ones now? There are R times S. This is why the product will be RS times 1. But RS, by assumption, is P. So I can say that this is P times 1. And P is the characteristic of D, therefore P times 1 must be 0. Diba? Oh. Ano ngayon na nangyari? Yung product ng dalawang ring elements na to, 0. We are in an integral domain, so what? The zero product property holds. The conclusion is that either R1 or 0 or S1 is 0. Why is this a contradiction? This is a contradiction because kakasabi lang natin si P yung characteristic. Pag sinabing characteristic si P, P is the smallest positive integer that can do this. Yet, si R at S ay mas maliit sa P at nagawa niya yung property na gusto natin. That contradicts the minimality of P. When you say minimality, by definition kasi P is the smallest to do that. Yet nakahanap ka ng mas maliit, si R or si S. That cannot be the case. Therefore, it cannot be that P is not prime. Kasi ang ibig sabihin nitong suppose that na ito, P is not prime, di ba? So therefore, the conclusion is that you cannot factor it in a non-trivial way. Therefore, P must be prime. Okay? So here are some of the consequences. Zn is an integral domain if and only if n is a prime. Consequence number 1. Alam nyo na yan, ha? Zn is a field, therefore, if and only if n is prime. Kasi nga, finite yan. Integral domain ang pinag-uusapan. At fields, parehas lang sila kapag finite. the characteristic of a field is either 0 or prime. Why? Because every field is an integral domain. An integral domain can only have a 0 or a prime characteristic. Therefore, for a field also, no, for a field itself, dapat ang characteristic din ay 0 or prime. Okay? So, meron ako isang theorem na i-represent and I would like you to think about this. Ang tawag natin dito yung natawag na freshman's dream theorem sa abstract algebra or sa ring theory. It says that if R is a commutative ring with characteristic n, kunwari ang characteristic ng ring ay n. Sabihin, nagsisiro yung sum ng a plus a plus a plus a if you're going to do that n times. Then for all a and b in R, a plus b raised to n equals a to the n plus b to the n. First of all, yung name na freshman's dream kasi, di ba kapag first timer sa algebra, karaniwan ganito ginagawa. Ang x plus y, pag i-square, ginagawang x squared plus y squared. It turns out that this is really the case. Basta ang characteristic ay n. Halimbawa, when you are working with z sub 5, no, for example, sa z sub 5, ang a plus b to the 5th, sadyang equal siya sa a to the 5th plus b to the 5th. So, hindi na siya mali. Nakuha niya? Tama na siya. Did you understand the point? True yan. Ano ba? Mag-example tayo. 2 plus 1 to the 5th. Anong 2 plus 1 to the 5th? Well, it's 3 to the 5th. Ano ba yung 3 to the 5th? Modulo 5. Hirap naman. Ano yung 3 to the 5th in the normal number system? Ano ba yung 3 to the 5th? Hirap naman.
243.
243, no? Tama ba? 243? Modulo 5. Ano remainder? 3, di ba?
3.
3 po.
Very good. O, subukan nyo naman yung 2 to the 5th plus 1 to the 5th. Ano yung 2 to the 5th? 32. Modulo 5, 2. 1 to the 5th is 1, of course, all the time. So, that's 1. 2 plus 1 is 3. Nakita nyo parehas to?
Opo.
Yes, because in any ring, as long as the characteristic is n, ang a plus b raised to n is equal to a to the n plus b to the n. Alam niyo yung proof na ito? It uses the binomial theorem. Diniscuss natin to last time. Diba? Yung binomial theorem na ito yung binomial theorem natin. In any commutative ring, this will work. Naku, nakalimutan ko. Ano ba to? Ganyan ba? Okay. Now, anong gagawin nyo to prove? This is just a consequence of the binomial theorem actually. Okay? The proof is like this. Ipapakita nyo lang na for k starting from 1 up to n minus 1, yung k, dinidivide niya yung n taken k. Yung n taken k daw divisible sa k, basta si k ay nagsisimula sa 1 hanggang n minus 1. Ito yung unang step sa pagpapakita niyan. I-simplify nyo lang yung n taken k. Di ba ganyan yan? I-justify nyo bakit ito divisible sa k. Pag nagawa nyo na yan, for k from 1 to n, ibig sabihin yung mga binomial coefficients na to are divisible by k. Pag divisible sa k, sabihin, inuulit mo nang inuulit itong term na ito ng n times where divisible sa k yung n. So, ibig sabihin, eventually, dahil ang characteristic ay n, magsisiro lang yung addition na yon. Kaya sa binomial expansion na to, 0 lahat ng dalawang terms maliban sa dalawa, yung una at saka yung dulo. Ang una, yung k is 0, yung last term is when k is n. Ito yung dalawa yun. Lahat ng mga nasa gitna nag-vanish because yung n taken k ay divisible sa mali ako, hindi pala k. Tama. Yung n taken k ay divisible sa k for k starting from 1 up to n minus 1. Ganun yung proof niyan. But I want you to do that on your own. Okay? May tanong ba muna bago tayo mag-proceed? Meron pa tayong lesson. Question so far. So I'm going to pause the recording para hindi In this slide now, we are going to talk about polynomial rings. Rings of polynomial sometimes. Ang ginagawa natin dito, whenever you have a ring, no? Tuturuan ko kayong mag-construct ng panibagong ring gamit yung lumang ring, no? By constructing a set of polynomials which themselves form a ring. Ang gulo, no? Ganito. May ring ka, halimbawa z sub 2 o kaya z sub 3. No? Ring yun. Gagawa ka ngayon ng mga polynomials na ang mga coefficients ay nanggagaling dito sa z sub 2 or sa z sub 3. Marami-rami yun, di ba? Mga polynomials na yun. Kukolektahin mo yung mga polynomials na yun. And then, i-define mo yung polynomial addition, tsaka yung polynomial multiplication. Makikita nyo yung set of all polynomials na magagawa nyo will also form a ring. So, parang we are constructing a new ring from the old one by considering constructing a polynomials out of the given ring elements. So, to explain this, meron na tayong ring of polynomials na napag-aralan dati. Diba? Last meeting. Sabi ko, pag sinulat ko yung z square bracket x, what I mean by this are the polynomials in x with integer coefficients just because z yung ginamit kong symbol doon, na? Alright? These are polynomials in x with integer coefficients. Ang operation na ito ay polynomial addition at polynomial multiplication. Makikita nyo mamaya that this is an integral domain. Okay? Ayan nga. In this lesson, our objective is we form a ring consisting of polynomials whose coefficients vary over an arbitrary commutative ring. Right? So in this lesson, pag sinulat ko si R, I always mean an arbitrary commutative ring. So here in this lesson, we are assuming that the multiplication is commutative. Kasi ang hirap mahirap kasing mag-multiply ng dalawang polynomials kung ang mga coefficients hindi nagko-commute under multiplication. That's kind of hard. Kaya to reduce the complications, we will just assume that the multiplication is also commutative. Okay? So this is what we mean by a polynomial. Okay? A polynomial over R. So, R is a commutative ring. In the symbol X, tinatawag nating indeterminate. Kung if you want to sound more fancy, no, you can call it the indeterminate. Sa mga books ng abstract algebra, ang tawag dyan, indeterminate. It's a formal expression of the form. No? Ibig sabihin ba niyan, sir, ang mga polynomials, infinite sum? Not really. Because, look at the definition. Meron kadugtong yan eh. Okay, ito lang ang polynomial where each AI ay nanggagaling dito sa R. That's easy to understand. For I greater than or equal to 0. Itong end, ito yung what makes it a polynomial. Na ito yung property that makes it a polynomial. Sabi nito, for some non-negative n, dapat yung AI ay magsi-0 for I greater than n. So, yung sabihin nito, darating yung time, ito yung n is 0, di ba? N is 0 to. N is 1, N is 2, N is 3. darating daw yung time where beyond that time, yung mga coefficients mo are already 0. So for example, hindi ito pwede. Halimbawa yung polynomial na to or expression na to, hindi pwede. We cannot call this a polynomial. Ba infinite yan na ganyan? This is not a polynomial. Why? Kasi yung property na ito, hindi nag-hold. Ang kailangan natin, after some time, or eventually, the coefficients must already all be 0. So, although my expression is infinite, no? But a real polynomial has only a finite number of non-zero terms. Hindi pa pwedeng may infinitely many non-zero term ka. Pag infinite yan na non-zero, hindi na yan polynomial. Ang tawag na dyan, power series. Diba? Sa ibang branch ng mathematics, especially sa calculus. The set of all polynomials of this form will be denoted by r square bracket x. So basically, ang polynomial, infinite talaga. Kaya lang natin sinusulat yung finite kasi yung mga susunod na terms actually zeros na. We just don't write it. Ayan. Para saan ba yung definition na yan? Or ba't ganyan yung pagkaka-define ni sir? Para ma-define natin yung degree ng maayos. The smallest such n, halimbawa, nag-zero na dito. Nag-zero na doon, and so on. So, yung n na tinutukoy dito ay 2. Kasi beyond that 2, 0 na. And totoo niyan, beyond 3 din. Halimbawa, bigay ako na example ha. 1 plus x plus 2x squared plus tas 0 na to. Oh, this is a polynomial, right? N is 2, n is 3, n is 4. Actually, beyond 2, di ba? Beyond 2, paglagpas ng 2, 0 na yung coefficients. Correct? But it is not the only integer where that will happen. In fact, when n is 3, beyond 3, the coefficients are also all 0. But the degree is not 3. Because it is not the smallest one for that to happen. The smallest one when that happens is when n is 2. Kaya nga ang tawag natin dun, we call that the degree of the polynomial. Sa high school, paano natin to sinasabi sa mga students natin? Paano nyo dinidefine yung degree ng polynomial?
Pinakamalaking exponent po.
Pinakamalaking exponent. No? Ganun natin yan dinidefine nyo sa high school. But of course, tayo yung nasa graduate school na, no, we are now studying formalities. No? Kaya ganito yung, naiiba na yung definition. Kasi we must understand that we as teachers must understand the subject in a deeper perspective down our students. Lagi tayong dapat one step ahead of our students. Diba? Ganun yun kapag teachers. Alam nyo naman yan. Kaya ganito yung definition. It might, tawag na ito, vary from the one that we are teaching. Pero of course, wag niyong gagawin ito sa mga students natin na high school. Especially, for example, ang mga students natin sa high school hindi pa familiar sa mga ganitong klaseng infinite na expression. They might find it uncomfortable to work with these types of expression. Kaya, you will define it the simplest way kasi anyway, ini-introduce pa lang naman natin yung algebra sa kanila. Diba? Okay. Kung ang degree ay n, ang tawag nyo dun sa coefficient or dun sa sa an, we call that the leading coefficient. Syempre lahat ng ring may 0. Sino kaya yung pumapapil na 0? Ang tawag dun, zero polynomial. The zero polynomial is defined to be the polynomial whose coefficients are all zeros. So formally, ganito ang itsura talaga ng zero polynomial. Pero di ba pag nagmamadali tayo, ganyan ba natin sinusulat ang zero polynomial? We just write it as 0. Kaya ko lang naman sinulat na ganyan because I want you to differentiate the symbol 0 or the number 0 from the polynomial 0. Although they are both 0, no? One is a polynomial, the other is just a number. Kumbaga, magkamukha sila ng notation, pero magkaibang entity sila sa math, no? Isa polynomial, isa ay zero. Paano nyo dinidefine ang degree ng zero polynomial noon? Kasi kapag zero ang polynomial, walang ganito eh. Wala kang makikitang ganito. In fact, sa simula pa lang, zero na. Diba? Paano nyo dinidefine ang degree ng zero polynomial sa high school? I don't know how you do this, actually. Wag nyo tignan yung definition ko. I wanted to know paano nyo... I'm curious kasi I haven't taught high school students before. Anybody? I think most of the high school books will not define the degree of the zero polynomial. Sasabihin lang, the zero polynomial, we do not define the, or the degree of the zero polynomial is not defined. Kasi parang wala siyang huling non-zero eh. From the start, zero na siya eh. Diba? Pero yung mga ganito, halimbawa, 1 plus 0x plus 0x squared, yan. Degree 0 to. Bakit degree 0? N is 0, n is 1. Kasi for I greater than 0, ai is 0, and 0 is the smallest integer for that to happen. Okay? Right? Kaya yung mga constant polynomials na tinatawag nyo, basta hindi 0, 0 ang degree. Pero yung zero polynomial, problema. Kasi ang magiging n mo na no, negative 1. Eh yung negative 1, hindi naman siya part nitong set na ito. So, magkakaproblema ka sa definition. To sometimes get away with the complications, we just say that we do not define the degree, or the zero polynomial has no degree. Or we do not define the degree. Ang ginagawa natin, sa abstract algebra, ang ating paraan is to just define it to be negative infinity. Symbol lang naman ito, huwag niyong pansinin. Hindi yan yung negative infinity sa calculus. That's just a symbol that represents the degree which is less than the degree of all the other degrees. Kung parang, kung may iba ka pang polynomial, laging mas maliit ang degree ng zero polynomial. Parang ganon. Ganun na lang yun. Okay? And then, two polynomials are deemed to be equal if their corresponding coefficients are equal. Ganun lang din yun. Maliwanag ito. So, ayan. Ito nga yung sinasabi ko. By convention, we assume that minus infinity will be less than n for all n in this set. For all non-negative n. Examples, yung kinalakihan yung polynomial na x cubed minus 2x minus 3 in z square bracket x, it actually means the following. Ito yung standard form, or ito yung formal form. Formal form, pangit. Yung formal way of writing the polynomial, minus 3 plus minus 2x plus 0x squared plus 1x cubed. Ganyan talaga yan, plus 0x the fourth. Nakita nyo, itong mga to ay integers. Anong degree ng polynomial na ito? 3. Kasi nangyari yung kahuli-hulihang hindi 0 ng coefficient dito sa x cubed. Therefore, the degree is 3. Susundin pa rin natin yung pangalan na yung naming system natin ng polynomials. Just like before, kapag degree 1, linear. Pag degree 2, quadratic. Pag degree 3, cubic, quartic, quintic. Na yung mga ganong klaseng. Tingin ko naman hanggang quintic lang ang may pangalan tayo. Hindi ko alam yung pangalan ng mga susunod. For example, in Z6 square bracket x. So, itong mga to, no? This is a quadratic polynomial. Pero alam nyo, in Z over Z sub 6, itong polynomial na to can also be written as follows. Why? Ano nangyari? Ba't yung negative 3x squared parehas lang sa 3x squared? Kasi in z sub 6, ang negative ng 3 ay 3. Dahil ang 3 plus 3 ay 0. So, I could replace minus 3x squared by 3x squared. Similarly, yung minus 4 sa z sub 6 ay 2 kasi ang 4 plus 2 ay 0. Kaya yung minus 4x here was replaced by plus 2x. So in Z6, there are many ways to write the same polynomial. Na? Do you understand what I mean to say?
Yes po.
Okay. Siyempre, para maging ring ito, then magdi-define tayo ng addition tsaka ng multiplication, right? So, ganito. Pag may dalawa kang polynomials like this, may mga certain degrees yan na we don't specify. Paano tayo nag-a-add? Paano natin tutuloy addition of polynomials? Combine similar terms. And formally, itong ibig sabihin natin ng combine similar terms. Yung mga constant terms, ina-add. Yung mga linear terms, yung mga quadratic terms, and so on. Okay? Multiplication is quite a work. Na? Kasi, paano mo i-define yung multiplication? Meron ka bang isang formula para sa multiplication? Diba? Sa high school, ang ginagawa natin, which is, we first teach them how to multiply monomials. And then, a monomial to several term polynomial, diba? And then, several terms to several term, hanggang matutunan na nila mag-multiply ng kahit na anong dalawang polynomial. Parang inductive ang ating style of teaching kapag high school kasi. But in higher mathematics, we tend to choose the deductive form of teaching. Kaya kailangan meron muna tayong general na definition. Paano natin i-define yan generally? This is quite complicated, but let me show you. We define the product of f and g. As you will see, ito lang din yung product na natutunan nyo dati. To be the polynomial with coefficients d0, d1, d2, and so on. Where ang definition ng dn is the following sum. I-expand ko to para makita nyo ha. Ayan. First term, A0, B1. Ibig sabihin, kinuha ko to. Ganon. Ay, A0. O, ganito. Magbigay tayo ng specific na, na example. Halimbawa, I wanted to get D1. How do I get D1? Mm-hmm. 1 minus k ito. So, ang first term, A0, B1. Diba? Second term, A1, B0. So, para daw malaman mo yung formula sa D1, ang kailangan mo ito, A0 times B1 plus A1 times B0. So, ito, tsaka yun. Bakit? Kasi yung dalawang factors na, yung dalawang, what do you call this? Sums, products na yun, yun yung magproproduce ng X. Nakita niya? Sige, para mas maganda yung pagpapaliwanag ko, let me use some table. No, ganito. Normally, dinidefine muna natin, this is how we teach our students in high school. No? First, magdi-define ka muna ng ganito, law of exponent. Tatawagin mong law of exponent yan. Tapos apply distributive property. Combine similar terms. In a more, what do you call this? Visual manner, ganito yan. You can create a table. Ito yung mga terms ng f of x. Ito naman yung mga terms ng g of x listed in some fashion. And then we're doing all the possible combinations and then write their product this way. Diba? Ganyan. And so on. And then what? we combine similar terms just like what I've told you. Halimbawa, ito constant ito, so nag-iisa lang siya. Yan yung D0. Okay? Next, yung mga X. Kukunin mo yung coefficient ng mga X. Ayan yung D1. Ito yun, no? Okay? D2. Dito yan manggagaling. Pag kinuha yung coefficients yan, anong mapapansin nyo? Sa D2, look at the subscripts. The subscripts, they all add up to 2 every term. 0 plus 2 is 2, 1 plus 1 is 2, 2 plus 0 is 2. Sa D sub 1, kukunin mo yung mga combinations na mag-a-add naman sa 1. Sa D3, yung mga combinations na mag-a-add sa 3. Halimbawa, what are those? A0B3, A1B, A0B3, A1B2, A2B1, A1B2, ano nga? A0B3 sa D3, no? Kunwari D3. A0B3, A1B2, A2B1, ganyan. Tapos A3B0. Yan naman yun.
3B0.
Very good. Ganyan siya, no? Yan yung definition natin kanina na may summation, no? Yun lang yung formalization, pero yun lang naman din. Ito lang din yung nakalakihan yung polynomial multiplication. Kaya huwag kayong matatakot, ha? So, halimbawa, this time, look at this. We're doing the calculations over which ring? Over Z sub 4. Okay? We're going to do that over Z sub 4. So, let's calculate the sum and product. So, I think we have to do this by hand kasi may drawing akong lapis. Ang addition naman, pinagtatapat-tapat nyo lang di ba? Ganyan, no? Tapos, 2x squared, 2x minus 1. Tapos, add mo lang as usual. Tatandaan nyo lang na kapag lumagpas ka sa 4, you have to do it modulo 4. So, 2x cubed plus x squared. Tulad nito, 4x. Ano yung 4x? Sa C sub 4 square bracket x?
0.
Oo, 0 yun. So, you don't need to write. Ito rin, 0 na rin to. So, the answer is the answer is 2x cubed plus x squared. How about the product? Pwede nyong gawin yung tinuro ko kanina. Tapos, pababa naman yung isa. Ganyan. O, tapos, do it like this. Negative 1, negative 2x, x squared, minus 2x cubed. 2x, 4x squared, (4x to the 4th). So, actually, zeros na to, no? 0 na rin to. Negative. Ang hirap naman. 0 na rin to. X to the 5. 0 na rin to. So, therefore, f of x times g of x equals yung pinakamataas na degree. Ito, no? Yan. Tapos, pag inad mo to,
Minus 4x cubed.
0 na rin yun. Magka-cancel yan. No? Kasi 4 yun eh. 4 is 0. Tapos ito,
3x squared.
yes, 3x squared. Tapos ito, x na rin yan. Ay, hindi. Tama. 0, di ba? Minus 1.
Negative
So,
1.
this must be the product. Or, alternatively, you can write 2x to the 4th plus 3x squared plus 3. That's the same. Ulit, bakit? Kasi ang negative 2 sa z sub 4 ay 2. Sometimes we tend to remove the negative sign para pare-parehas tayo ng sagot. No? Ang negative 2 ay 2 2 din kasi ang 2 plus 2 ay 0. Ang negative 1, for example, ay 3 kasi ang 1 plus 3 ay 0. So you can write your answer this way or this way, alin man dyan. Sabi ko nga, this time, maraming paraan to write your polynomials kasi you're doing it modulo 4 in CSAG 4. Okay? Do you understand how to add and multiply? Ito pa rin naman yung dati. Except may ginagawa lang tayong kakaiba ngayon. Okay. May napansin kayo sa degrees? In a normal algebra, no? In a normal class in algebra, what do we teach our students about the degree of the product? Let's say I have a degree 2 polynomial, I multiply it with a degree 5 polynomial. What do you expect about the degree of the product? Sige nga, anybody? What do you expect about the degree? Wait lang. I'll think about that for a while ha. May kukunin lang ako. May sagot na ba? O yan, sabi ni Molan, ma-add daw po. Ibig sabihin nun, kung degree 2, minultiply ko sa degree 5, ang expect nyong product ay degree what? 7. Degree 2 tsaka degree 5, ang product hindi sum. Yung sum yata sinasabi ni Sheena. Tama ba ako? Yung sum in-expect mo 5. Pero sometimes it gets low. Pag sum lumiliit kasi pwedeng mag-cancel yung mga highest degree terms. Ano ba? Negative x cubed plus 2x, i-add mo sa x cubed plus x. O, di ba? Pwedeng lumiit. Sa product, ang interesting. Kasi sa normal na algebra, ina-add mo. Di ba? Pero sa, tignan nyo to. This is degree 3. This is degree 2. But the product is degree 4. So, yung property na yon hina-highlight ko, no? Kasi ito yung mga properties na dati mong ini-expect or dati mo nang ini-expect na in general, hindi siya laging totoo. Pansin nyo, yun yung ginagawa natin, no? Yung mga properties that you were exposed to before na hindi palagi palang totoo yun in some setting. Totoo lang siya kasi mga real numbers yung mga nilalaro natin noon. Okay. But before talking about that property, let me just state the following. Pag commutative ring si R, yung R square bracket X, yung mga polynomials yan, bumubuo rin ng commutative ring. Alam nyo bakit? Kasi, the way we multiply and add polynomials, we follow the rules in a commutative ring, di ba? So, naturally, yung mga rules na yun, yung associative property, commutative property, it will extend to the polynomials kasi parang gumagamit ka lang naman ng distributive property. In fact, if the ring R has a unity, yung ring of polynomials mo rin, may unity rin yun. At ang multiplicative identity mo, yung element na 1. But of course, we're talking about polynomial. So, yung 1 natin is actually 1 plus 0x plus 0x squared plus 0x cubed plus and so on. Okay? I don't think I need to elaborate this one kasi i-check mo lang naman na yung addition of polynomials, associative, no? Yung mga ganun, commutative, may 0, may multiplicative inverses, etc. Associative ang multiplication, right? Kagaya ng mga ganun. Ito yung interesting. yung degree sum property na yun, sum of the degrees, yung degree ng f of x times g of x, nagiging equal sa sum ng degree, meron kayong kailangan para mangyari yun. What is that? Ano yung needed assumption para mangyari yung equation na ito? Ha? Ano yung needed assumption para mangyari yung gusto nating mangyari? Bakit kaya nag-work yun dati? Ito dati. Ang requirement, dapat yung coefficients mo must come from an integral domain. Isa sa mga mahalagang contribution niya ng mga integral domains. Yung degree sum formula nag-hold basta yung ring of coefficients ay bumubuo ng integral domain. Bakit kaya? Halimbawa kasi si f of x degree n. So, sabihin niya yung f of x mo ganito itsura. an xn plus ganyan, no? Kunwari lang. A0. Tapos yung an mo dito hindi 0 kasi yun yung degree. Kunwari naman ang degree ng g ay m. So, ang g of x kunwari bm xm. Like so. Pm is not 0. Pag kasi minultiply mo yan, based on your experience, ano yung pinakamataas na degree ng term na ito? Ha? Ano yung pinakamataas na degree? Diba ito? Ang first term na ito, an, bm, x raised to n plus m. Ito yung pinakamataas. Yung mga leading terms gets multiplied to get the leading term of the product. Plus blah 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 blah. Wala ka nang pakialam sa susunod. Ito lang kailangan nyo. The fact that an is not 0 and bm is not 0 because we are working with an integral domain, this product remains to be not 0. So therefore, the degree of the product is equal to n plus m, which is the degree of f plus the degree of g. Naintindihan nyo ba? Naintindihan nyo so far? Okay. May second claim tayo. The units. Ano yung sabihin ng units? Yung mga elements na may multiplicative inverse. The units of this polynomial ring are precisely the units of D when you view them as constant polynomials. Naintindihan nyo? Ang mga may multiplicative inverse lang na polynomial ay yung mga constant polynomials na may multiplicative inverse din. By the way, may complete proofs itong mga ito ha. Yung mga pinapaliwanag ko lang yung mga proofs in the shortest way possible. Kasi remember, tayo ay 3 hours lamang in a week sa live, no? You can still read them in details doon sa lecture notes. I think I've written the explanations there. Ang magiging consequence nito ito. Kung si D ay integral domain, yung mga polynomials din na mabubuo mo out of D will also form an integral domain. Kasi kapag non-zero polynomial yung f of x, non-zero polynomial din yung g of x, pag minumultiply mo naman yung f of x times g of x, you're just combining all the terms, di ba? Term by term, lahat ng mga possible combinations. Tama ba ako? Lahat ng mga possible combinations lang yun. Eh kung mga non-zero, may non-zero coefficients ka sa bawat isang polynomial, magmamatch yung dalawa, certainly, meron ka ng non-zero na term. So therefore, the product is also a non-zero polynomial. Kaya, in fact, dahil din yun sa number 1. Halimbawa, si f of x degree, hindi siya 0 eh. So, positive ay non-negative ang degree. Let's say, degree 2. Ito, degree 3. So, yung sum, ay yung product ay degree 5. So, never siyang zero polynomial. Did you understand? Tandaan nyo na. Halimbawa, ito. Sige nga, kanyang multiply, kayo naman. Anong product na ito? In Z6 square bracket X. Anybody, anong sagot dito?
Parang 0, sir.
Zero, no? So, this means what? Thank you, Leonard. This means what? Non-zero. Non-zero. But the product is zero. So, that is what? That is a negative property, di ba? So, something that we don't like to happen in a ring. So, sabihin, si C6 square bracket X, ano to? This is not what? An integral domain. Maybe because Z6 is not an integral domain. Di ba? Kanina kasi kung yung ring ay integral domain, sure ka na ito integral domain. Si C6 kasi hindi integral domain because 6 is not prime. Intindihan nyo? May tanong ako susunod. I-level up natin. Kasi ang pinakamahigpit sa lahat yung field, di ba? Ano nga yung hierarchy natin? Commutative ring with unity. Ito yung mga integral domains. Ito yung mga field. So, ang pinaka-strict sa tatlo, yung mga field. Halimbawa si Fi field. Ayun. What can be said about F square bracket X? Ano yung field? Ito yung mga yung mga commutative ring with unity na ang mga non-zero elements ay may multiplicative inverses. Ano masasabi natin sa F square bracket X? Field din ba siya? Kasi kapag kanina, pag integral domain to, di ba? Ganun yung kanina eh. Inaasahan ba natin na kapag field ito na yung I field? Look at this example. Let's look at the field Q of rational numbers. Let's just look at the polynomial X. Is the polynomial X a unit? When you say unit, siya ba ay may multiplicative inverse na polynomial din? Can I find a polynomial over here so that the product is 1? I mean 1 the polynomial. Tignan natin. Kunwari meron. Ito kunwari siya. Pero pag minultiply mo yan, ganito mangyari, di ba? A0x plus A1x squared. Actually, may 0 ka dito ngayon. A2x to the 4th plus and so on. Mag-i-equal siya sa 1 plus 0x plus 0x squared. Equating corresponding coefficients, ang mangyayari, 0 will equal to 1. Of course, this is a contradiction. Ang sabihin yan, a contradiction. So, pag sinabing, pag may nangyaring contradiction, ibig sabihin, this can't exist. Ibig sabihin, x is a polynomial which does not have a multiplicative inverse. So, x is not a unit. Yet, it is not 0. Therefore, the answer to this question is no. Because we were able to find one non-zero polynomial in Q square bracket X, where we were able to prove that it is not a unit or it doesn't have a multiplicative inverse. Sa madaling sabi, yung 1 over x hindi siya polynomial. Kasi supposedly para maging 1 yung x, multiply mo sa 1 over x, di ba? Pero, hindi kasi siya polynomial. Kumbaga, pinunod ko lang na hindi ka makakahanap ng iba pang polynomial na pwedeng i-multiply sa x para maging 1. Do you understand the argument? Why is there a need to do this? Di ba? Kasi kapag sinabi mo lang sa akin, kasi sir, yung 1 over x hindi naman siya polynomial. Yes, it's not a polynomial, but it doesn't imply na walang polynomial ang pwede mong i-multiply kay x para maging 1. Kaya ako ginawa ito. Kunwari may polynomial na nag-e-exist na mamumultiply ko sa x para maging 1. Ang naging consequence in the end, 0 is equal to 1. Of course, that's a clear contradiction. Therefore, such a polynomial cannot exist. So, maliban sa ang 1 over x ay hindi polynomial, na-prove mo pa na wala kang ibang polynomial na maimumultiply sa x. So, that the product is 1. Okay. Naalala nyo ito? Ang tawag dito ay division algorithm for z. For the integers. Kasi, remember, if you have an integer n and you have a positive integer d, you can always divide n by d. Makakakuha ka ng tinatawag na quotient tsaka remainder sa basic arithmetic. No? More formally, ganito siya. If you have integers n and d, where d is positive, then according to the division algorithm for z, you can find unique integers q and r, so that n is qd plus r. Where r, it's not just an integer, it satisfies this restriction. This r can only be greater than or equal to 0 but less than d. Did you understand? Ang tawag nga natin dun sa q at r na yan, yun yung quotient at remainder when n is divided by d. Sige nga, exercise tayo. Halimbawa ang n ay 39, ang d ko kunwari 5. Ano ang q at r?
Q is equal to 7, R is equal to 4.
Yes, no? Q is 7 and R is 4. The quotient is 7, the remainder is 4. In fact, ang 39 kasi can be written as QD. 7 times 5 plus 4. Right? And 4 satisfies this inequality. Kasi pag hindi mo sinulat yung restriction na ito, maraming Q at R ka makikita. In fact, maglagay ka lang ng some Q, makakahanap ka na ng R eh. Kahit na anong Q, makakahanap ka ng R. Yung restriction na to makes these integers unique, kaya pwede mo siyang bigyan ng pangalan. Kaya pinibigyan natin siya ng name na quotient and remainder. Right? Halimbawa, ang N ay negative 39, ang D naman ay 5 pa rin. Ano ang Q at R? Sige. Anong Q? Negative 7. Ano ang Q? Wala, nalito na. Nag-negative lang, nalito na. Kasi when we were younger, we were not taught how to divide a negative thing, di ba? Paano to? Anong Q at R natin? You can post them in the chat box if you're shy to open your mic. Ano, wala kayong sagot? Anong Q? Negative 7? No, Q must be minus 8. Bakit dapat minus 8? Para ang QD ay negative 40. Ang R ko ngayon magiging 1. Nakuha nyo, why must it be minus 8 and 1? Kasi ang 40 ay negative 39 ay negative 8 times 5 plus 1. 1 still satisfies that inequality. So, ang quotient, pag dinivide mo yung negative 39 sa 5, hindi na 7, ha? Ang sagot ay negative, hindi na negative 7, it's negative 8, para ang remainder ay 1. Kasi kapag di-negative 7 mo yan, ano mangyayari? Pag di-negative 7 mo kasi yan, ano ba? Negative 35 to. So, para maging negative 39, ang remainder mo magiging negative 4.
Negative.
It's not allowed. Diba? The remainder has to be either 0, 1, 2, 3, or 4. Yun lang ang pwedeng remainder. So, this is not the correct way. Ito yung sinasabi ko. Sa totoong buhay, pag wala itong restriction na to, hindi unique yung mga integers na yan. Because of these restrictions, the values for Q and R will be unique. Saan ba pinuprove ito? Or saan ba pinag-aaralan ito? Sa number theory, kapag nag-enroll yan ng number theory, I think your teacher will demonstrate the proof of this division algorithm. Now, ba't ko diniscuss ito? This is one advantage when the ring of coefficients is actually a field. Kapag ang ring of coefficient ay field, ano? Yung division algorithm ay nag-extend dun sa ring of polynomials na f square bracket x. Ano ibig sabihin nun? Pag may dalawa kang polynomials, f of x and d of x, where d of x is non-zero, then we can prove that polynomials q and r exists. They are unique. So that f of x is q of x times d of x plus r of x. And that we require that the degree of r of x, ito yung remainder kasi, is less than the degree of d of x. Ang tawag natin dito ay division algorithm for f square bracket x, or for the ring of polynomials. And this theorem is true only when the ring of coefficient is a field. Hindi integral domain, kailangan field. Isa to sa mga advantage kapag field. Bakit dapat field, sir? Kasi kapag titingnan nyo yung proof na ito, meron tong proof dun sa lecture. I wish to discuss the proof sana, kaya lang, sabi ko nga, limited yung time. Labas natin yung lecture notes natin. Hanapin ko, ha. Ayan, ito yung notes na nandoon sa, ayusin ko lang. Ito yung notes na nandoon sa, tawag ito? Sa Google Classroom. Nakikita nyo na ba yung notes? Ayan, ito yung division algorithm for f. May konting changes lang dito. Meron ako dito sinulat na where r of x is 0 or degree of r of x is less than the degree of d of x. Kasi kapag ang r of x ay 0 naman, ang degree niya negative infinity. Totoo pa rin ito. Ito yung gamit, ba't gusto kong i-define to be negative infinity? Para yung where na ito, hindi ko na kailangang isa-isahin. Hindi ko na kailangan dalawahin. Kumbaga, itong isang inequality na to will generalize everything. You don't need to write that. Since we have already defined the degree of the zero polynomial to be negative infinity, pwedeng ito na lang ang isulat mo. Okay? Ang proof na ito ganito. Yan o. Ipaprove mo muna na nag-exist yung Q at R. Anong ginawa dito sa proof? Ang ginawa sa proof ay induction. Proof by induction. Strong induction, in fact, ang ginamit dito. But, nakita nyo dito, no? Kung iba-browse nyo lang, mabuti paano hinanap yung mga polynomials na Q at R. Gumamit dito ng BM inverse where BM is not 0. Ibig sabihin, nire-require talaga, kailangan talaga yung ring natin ay filled para mag-exist ito. Pag hindi filled yan, hindi ka sure na mag-exist yan kasi. Naintindihan nyo? But if you're going to watch closely this process or this induction, ito lang siya. Meron ako ditong parang yung nanggaling siya doon sa long division na tinuro sa atin nung high school tayo. Ayan o, yung mga sagot na ito, ano ba ito? Minultiply ito dito, ito yung u of x. Ay, sinubtract, ito pala yun. Tapos, sinubtract mo, yun yung u of x. Nakuha niya? Diyan ang galing yan. Yung long division. Kung uungkatin mo yung proof nito, that's very, what do you call this? Yung proof kasi nito, very intricate. Medyo, So, I would rather ask you to just read it kaysa maubos yung time natin ngayon. Ito naman yung proof of uniqueness, proof of existence. Okay, in existence, we use induction. Yung uniqueness, yun, ginamit nga yung inequality na to prove the uniqueness, to force uniqueness. And as always, ang tawag natin dito ay quotient at remainder. Wait, I think my connection is being unstable right now. Naririnig nyo pa ba ako? May
Yes, sir.
lumalabas, your connection is unstable.
Okay ba naman?
Okay naman. O, sige. Ganito. Magpunta na lang tayo sa isang particular na example. Halimbawa, I have two polynomials, 4x cubed plus 2x squared plus 4. Yan. Tapos, i-divide natin, let's say, sa 3x squared plus 2x plus 1. Pero this time, sawa na tayo mag-divide sa over the real numbers, right? Tingnan natin kung kaya natin gawin sa z5 square bracket x. Remember, because z5 is prime, z5 will be a field. So, therefore, applicable yung division algorithm doon sa case na ito. And also, kaya tinawag na division algorithm for your information. Sabi ko nga, kasi yung proof nang galing dun sa algorithm kung paano natin kinukuha yung quotient at saka yung remainder. Okay? Paano to ginagawa? At ginagawa lang din yung usual. Paano yung usual ba? Sige nga, susulat ko 4. Masyadong maliit yung sulat ko. 4x cubed plus 2x squared plus 2x squared plus 4x plus 3. I'm going to divide that by 3x squared plus 2x plus 1. Kailangan dito meron kang scratch. Isa pang kailangan mo, kunin mo na yung inverse nung bawat isa beforehand. Siyempre, yung 0 wala. 1 inverse is 1. Anong 2 inverse sa z sub 5? Anong i-multiply ko sa 2 para maging 1? Try mo isa-isa. 2 times 1, 2. 2 times 2, 4. Hindi. 2 times 3, 6, 1. Ayun. So, therefore, ang inverse ng 2 ay 3. At ang inverse naman ng 3, syempre, vice versa yan, 2. Ang inverse ng 4, ano?
1?
4 times 1 is 4.
4.
4 times 4 is 16. Therefore, 1. So, ang inverse ng 4, sarili niya. Okay, ganito yan. Di ba ang unang step na tinuro sa inyo, look at this, di ba? Ganon. I-divide. So, you have to divide 4 divided by 3. Wala ka namang 4/3 dito. Huwag ka mag-iimbento. Ang 4/3 natin talaga is 4 times 3 inverse. Yan ang meaning natin nun. And because 3 inverse is What is that? 2. Ang ingay naman ng basurahan. Naririnig niyo ba? Oh. Ano yung 4 times 2?
3?
3. Kasi that's 8 modulo 5. So, kaya ang 4/3 natin dito ay 3. Kaya ang sagot dito, 3x. Diba? Pa 3x. Kasi x cube over x squared nagiging x yun. Diba? And then, i-multiply natin to isa-isa. Then 3x na to gets multiplied to this. Magiging 3 times 3, 9. Modulo 4 at 5, 4. 3 times 2, x squared. 3 times 1, 3x. So, subtract. Naku, magsusubtract ka na naman. 0 na to. 2x squared minus x squared. X squared. 4x minus 3x, x. Baba mo yung 3. Ang degree ba nito mas maliit na sa degree nito? Hindi, no? Equal pa sila ng degree. You don't stop until... Uulitin mo lang, kaya nga induction yung proof nito eh. Hindi ka titigil until a certain condition is hit. Yung condition, kailangan yung difference na ito, lumiit na yung degree niya dito. But this time, the degrees are still equal. Kailangan less than. That's the time you have to stop. Kasi the degree of the remainder has to be less than the degree of the divisor. So, you still divide. X cubed over 3x squared. Kailangan mo ngayon yung 1/3. 1/3 is 3 inverse lang naman.
2.
2. Kasi ko dito, plus 2. Okay? So, multiply mo ulit. X squared plus 4x plus 2. Okay, subtract. Wala na to. Minus 3x. Ano may minus 3x sa z sub 5? Kuwari matalino ka, gaganyan-ganyan ka. No? Mga klasiko ng elementary, kapag gumaganyan, yun pala malabo lang mata. Akala ko nung maliit ako, kapag gumaganyan yung mga klasiko, yun yung mga matatalino. No, ano yung negative 3x? Pwede nyo isulat negative 3x actually. Wala namang kaso yun. But, para lang walang negativity sa buhay, pwede nyo isulat to ng 2x lang. Kasi, ang negative 3 sa z sub 5 ay 2. Kaya ito 2x plus 1. So, I think we're done. Ang quotient ay 3x plus 2. Ang remainder ay 2x plus 1. How do I know na tapos na? Kasi yung degree na ito ngayon, 1 na ang degree. Ang degree na ito ay 2. Okay? O yung form na gusto nyo, yung ito yun, 4x cubed plus 2x squared plus 4x plus 3. Ang quotient ay 3x plus 2. Ang divisor ay 3x squared plus 2x plus 1 at ang remainder ay 2x plus 1. Okay? Yan yung ano. Yan ang yeah. Ito yung qx d of x r of x. Okay? May tanong ba? O, paano mo ma-check kung tama yung sagot mo pala? How would you check if you have the correct answer?
Kapag po nag-equal ang both sides.
Oo, so you have to perform this, i-reverse engineering mo to, no? I-multiply mo, tapos i-add mo to, tapos tingnan mo kung ito yung lalabas. But you're going to do that over z sub 5 as well. O kaya kung tinatamad ka, gusto mo i-check, o di-check mo, check. Bigyan mo sarili mo ng 10 points. Charot. Naintindihan niyo? So to summarize everything in this slide, ito. Let R be a commutative ring with unity. Conclusion number 1, the ring of polynomials created from R is also a commutative ring with unity. In fact, if R is an integral domain, then so is R square bracket X. But remember, if R is a field, it doesn't mean that R square bracket X is a field. Ang sure lang tayo yung F square bracket X, integral domain din kasi ang field ay integral domain. Ang maganda naman kapag si R ay field, yung division algorithm ay nag-hold. So, meron tayong tool na pwedeng gamitin later. Ang tawag dyan ay division algorithm. Okay, so pag sinabi ni sir, by the division algorithm, there exist polynomials. Ito yung tinutukoy ko. Sabihin, when you actually met these polynomials, actual polynomials, i-divide mo siya gamit ang long division. Yun ang sabihin ko ng word na division algorithm. Naintindihan nyo ba? Hindi pa tayo tapos ha. Meron pa tayong ilang minuto. But next week, maybe mapag-uusapan natin mga roots ng polynomials na, no? Or hindi ko alam. Kasi alam nyo, meron akong mga topics na i-skip. Susubukan kong kasi 6 weeks lang tayo. Hindi ko alam paano pagkakasyahin eh. Or kung saan na lang tayo makaabot siguro, kung ano lang yung most relevant din yung ating itatouch. As an activity, online activity ito, pero sana meron kayo sa bahay na anong tawag yun? Papel de hapon. Meron ba kayong papel de hapon na makukuha? Or anything, onion skin paper, yung mga maninipis na papel, i-pause ko muna yung recording ha. So, here, sabi ko nga, we will be talking about subrings and ideals. Ang subrings, from the word itself, kasi diba ang set may subset. Diba? Ang mga rings, may subrings. Ano yung sabihin ng subrings? Subset lang naman siya ng ring na bumubuo rin ng ring. Naintindihan niya? Ring na nasa loob ng mas malaking ring. Kasi you have seen something like this on in my previous examples. Ang ideals naman is a special kind of subring na may additional property. Okay? May additional property yung ideal na yan, which will be useful to us later. Magagamit itong concept ng ideals, no? Later, kasi kapag halimbawa may polynomial ka, let's say, the polynomial x squared plus 1, ito yung nasa r square bracket x. Diba? What's bad about this polynomial is that in r square bracket x, this doesn't have a root, a real root. Diba? Alam nyo sa elementary algebra, x squared plus 1, it cannot even be factored into linear factors in r or in r square bracket x. Wala rin siyang root. Hindi ba? Pero, ano masasabi niya dito? Wala man siyang root sa R, pag pinalaki mo yung viewfinder mo, yung paningin mo, nilawakan mo yung pag-iisip mo, inextend mo sa mga complex numbers ngayon, no? Makakahanap ka na ng root niyan eh. Ang root niya yung tinatawag nating I. Kumbaga, wala man siyang root sa R square bracket X, sa R, pwede mong lawakan si R, magdagdag ng element sa R para yung polynomial na ito ay may root na. And we are kind of doing this in general later. It turns out na kapag may polynomial ka in any ring, no, over any ring, in any field, I think, over any field, tas walang root yung polynomial na yun on that field, meron tayong paraan to construct a field larger than the original field which will contain roots to the polynomials. Kumbaga, wala kang root nung una simply because maybe the field is kind of fault. Yung field na may kasalanan doon, masyado siyang maliit to contain the roots of the polynomials. But according to that, certain theorem later, nagagamitan natin ng ideals, makakahanap ka ng field larger than your given field, which will contain roots to that polynomials that we cannot solve. Naintindihan nyo ba ako? Yun yung abstract na perspective dito. I mean, yun yung abstract na gagawin natin later. And using ideals, and the theorem uses ideals, or the idea uses ideals. Sige. So, ito na nga. Sabi ko, given a ring R, we are really interested to know subsets of R which form a ring under the induced operations in R. Pag sinabi kong induced operations in R, mamanahin lang, kasi ito si R, kukuha ka lang ng subset niya, let's say, S. Nasa loob lang naman din siya ng R. So, yung operation ni R na addition tsaka multiplication, gagana rin yan sa mga elements ng S. So, kumbaga, pwede mong hiramin yung addition ni R tsaka yung multiplication ni R to, what do you call this? To have operations in S. At gusto nating malaman, sino mga subsets ang bubuo ng ring din? Okay. So, these are the tests. This is actually the definition, but basically, ito yung mga tests na kailangan yung gawin to test whether a given subset is a subring. May tatlong conditions kayong kailangang i-check para ma-ensure na yung subset na yun ay bubuo ng subring. Take note, hindi lang tayo naghahanap ng subset, naghahanap tayo ng subset na ring din under the same operations as that of R. So, ano yung tatlong conditions? Kapag pala si S ay subring ni R, we use this notation. Looks familiar, no? Sa elementary algebra, basa natin yun, less than or equal. Pero dun sa less than or equal, ang kino-compare natin, dalawang numbers. Dito kasi, ang kino-compare natin, dalawang rings, no? So, kapag ito yung mga rings, yung less than or equal, it doesn't mean less than or equal. We actually mean the subring relationship. Sabihin si S ay subring ni R. Si S ay nasa loob ni R as a ring. Anong tatlong conditions na kailangan natin? Nalilito ko sa camera kasi tatlong mirrored, baligtad. Tatlong conditions. Una, dapat yung, di ba, ring R being a ring, meron siyang 0. Dapat yung 0 element na yun, siya yung kauna-unahang element ng S. Dapat nasa S siya, nasa subset siya. Kaya kapag may subset ka na wala yung 0 ng R doon, tapon mo na yun, hindi yun subring, hindi yun magiging subring. Kasi, first of all, hindi siya magkakaroon ng 0 because yung 0 na dapat niya, na 0, ay wala sa kanya. Second, dapat closed under subtraction. What do I mean by that? Anong sabihin ni sir sa closed under subtraction? Dapat, pag may dalawang elements ka kay S, yung difference nila, dapat nasa S pa rin. Did you understand? Halimbawa, nakakita ka ng dalawang elements sa S nung sinubtract mo, wala sa S yung sagot, ay, hindi yan subring. Automatic, tapon mo na. Naintindihan nyo ba? Finally, dapat closed under multiplication. Kailangan ang product ng dalawang bagay na nasa S pa rin. And when these three conditions hold, guaranteed, yung subset na yun ay subring. Kasi, first of all, hindi mo na i-check yung commutative property, associative property. No need. Kasi, hiniram mo lang naman yung same na operation mula sa R. Alam mo na yun ay commutative at associative in the first place. So, no need to check for that. Ang i-check mo na lang yung mga possible complications na, naku, baka pag nag-add ako, yung sum wala doon sa S. That's not good. So, kailangan 0 is in S, closed under subtraction, closed under multiplication. Kaya nga nasabi ko, if these three conditions hold, then S is a ring itself under the induced operation of R. With respect to the addition, kasi ito yung abelian group, di ba? ito rin ay magiging abelian group at in fact, nasa loob siya ng group na yan. Kung ano man ang isabihin ng group, you can, dun sa mga bagong dating, you can rewatch the last week's video. Lahat ng ring, may automatic na subrings. May dalawang automatic na subring. Yung sarili niya, syempre, a set is a subset of itself, di ba? Yung sarili niya is a subring, at siya yung pinakamalaking subring, whereas, ito naman yung pinakamaliit na subring. Ang pinakamaliit na subring na possible is the subset containing only the zero of the ring. Dito, ang 0 minus 0 kasi 0, di ba? Ang 0 times 0 ay 0. Kaya check ito, check ito, check ito. Ito yung pinakamaliit na subset na masasatisfy itong property na ito. Kaya, siya yung pinakamaliit na subring. Pero alam nyo, of course, in our study, hindi tayo interesado sa dalawang subrings na yan. Kasi sila yung mga trivial na subrings. Ang interested tayo, yung mga subrings larger than this, but smaller than this. Yung mga nasa gitna. Hindi kasing liit ng 0 na subring, hindi siya kasing laki nung ring itself. For example, ito yung sikat na subring relation, no? The set of integers forms a subring of the set of rational numbers kasi yung mga integers ay rationals, di ba? Yung mga rational numbers, it forms a ring and it's inside the set R, right? And the real numbers are just examples of complex numbers. Ang pinakamalaki sa kanila yung C. Parang tower of rings ito. Bigay tayo ng example na iba. Okay. Pag nakita nyo itong symbol na ito, what I mean by this are the real numbers of the form a plus b square root of 2, where a and b are integers. Halimbawa, 2 plus 3 square root of 2, nandyan yan sa set na ito. What else are in this set? Yung negative square root of 2, nandyan din kasi ito'y 0 plus negative 1 square root of 2. Diba? Halimbawa, yung 1 plus square root of 2, nandyan din siya, di ba? What else is there? How about 1 plus square root of 2 over 2? This is no longer in z square bracket 2, square root of 2. Kasi parehas to sa 1 half plus 1 half square root of 2. Remember, ang requirements natin, yung a and b dapat integers. So, hindi lahat ng real numbers ay nandito. Halimbawa, square root of 3 is not found there. Itong subset na ito, it actually forms a subring of R. Why? Let me illustrate to you why. First of all, yung zero element, pwede mo kasing isulat yung 0 as 0 plus 0 square root of 2, right? So, it's found in this subset. So, condition number 1 holds. Number 2, closure for subtraction. Pag kumuha ka ng dalawang elements kasi niya, at sinubtract mo ng ganyan, paano ba tayo nagsusubtract ng ganyan? Ganito yan, no, di ba? A1 minus A2 plus B1 minus B2. Now, remember, A1, A2, B1, B2 are integers. Therefore, this is an integer, and this is another integer. Therefore, this expression is again in z square bracket square root of 2. Okay? Later, ipapaliwanag ko yung notation na to, ba't ganyan yung notation. But for now, huwag nyo munang isipin. Paano naman pag nang-multiply? Pag minultiply mo naman ito gamit ang normal na algebra, ganyan, tapos kinombine mo yung mga similar terms, no? It will simplify to this. Integer din ito for sure. Integer din naman ito for sure. Naintindihan nyo ba? Therefore, the product falls inside z squared bracket square root of 2. Hence, the three conditions or the three axioms for a subring are satisfied. So this is really a subring. So pag sinabi kong show that this is a subring, ganyan ang gagawin nyo. Yung tatlong conditions, kailangan i-check nyo that it is satisfied. Okay, let me introduce another subring. This time, of the ring Z of integers. Mag-fix ka ng integer n, and then look at nz. Pag nakita nyo sa blackboard yung nz, halimbawa 4z. Alam mo ng 4z, yung mga 4k. Okay? In other words, ito yung mga multiples ng 4. 0, plus minus 4, plus minus 8, plus minus 12, and so on. Subring yan. Kasi check nyo. Ang 0 ba nandyan? Ang 0 ba multiple ng 4? Yes. 0 is 0 times 4. Or 4 times 0, for that matter. If I subtract 2 multiples of 4, do I get another multiple of 4? Yes, once again. If I multiply 2 multiples of 4, do I get another multiple of 4? Yes. And you can generalize that for any n. Okay, so yung mga nz's, they are clear subrings of z. Huwag nyo nang basahin yan. Tingnan na lang natin yung z sub 10. When you look at this subset, marami to 0 hanggang 9, di ba? Pero kukunin ko lang yung 0, 2, 4, 6, 8. Now here, look at this. I have created here the addition and multiplication table for z sub 10. For s. Nakita nyo, when you look at the sum and the products, may lumabas bang 3? May lumabas bang 7? Wala naman, di ba? Ang mga lumabas lang ay isa rin sa mga 0, 2, 4, 6, at 8. Right? So, close siya under subtraction and multiplication. So, walang lalabas na weird. Pero halimbawa, itong 0, 1, 2, subring ba to ng ng z sub 10? Hindi, kasi ang 1 plus 2 ay 3. Wala naman yan sa z sub 10. Diba? Kailangan closed under the operations. But in this case, yung s na ito ay subring. Now, alam yung interesting dito? Ito, look at this. Si c sub 10 ay ring, commutative ring with unity. In fact, ang unity ni 10 ay 1. When you say unity, multiplicative identity. May tanong ako, si S ba may unity? Anybody?
Wala, sir.
Wala ba? Check nyo mabuti. Titignan nyo ito, ha? Wala. Mali kayo. Meron siyang unity, hindi na nga lang 1. Sige. Alamin nyo nga anong unity ng S?
0.
Di ang 0, pag binultiply mo sa kahit sino, 0. Ang unity, kailangan, kung sino man ang multiply mo sa kanya, ang lalabas yung kung sino.
I know.
Ano?
6.
6, di ba? Di ba to get
6.
the unity, ang hinahanap natin, kung kailan mauulit to. Ito dito. So, therefore, 6 is the unity. Ito rin, tingnan nyo. Sagot, yes. The answer is 6. Pwede pala yun, sir. Of course, yes. This is one, tawag nito? Weird property of subrings. Kahit na subring ka, hindi minamana yung unity. Naintindihan nyo ba? Okay? Hindi minamana yung unity. Now, dahil 11:59 na, I have to cut the lecture from here and we will just what do you call this? We will just continue next week. For now, I am accepting questions now before we end. Stop ko na yung recording ha.